Hello Year 7s, this term we are testing you on your graphing skills, so let's get on with it. First, what is a graph? A graph is a diagram that shows a relation between two variables, so you're comparing two things. Okay, so for example, here we have the growth of trees over a period of time. So what are we testing? We are testing how much our tree will grow in a certain time. So you can say, I'm going to compare the growth of trees in meters over the time being, let's say, weeks. The amount of distance traveled on a certain time interval. So let's say that you ask a friend to time you. How long will it take you to travel, let's say, 50 meters when you're running? The price of sugar depending on the demand for it. So a rule of thumb, we're comparing here the price of sugar with the demand, that is how much people want sugar. So a rule of thumb is that the higher the demand, the higher the price. The same thing happens backward. The less demand, the less the price. We can compare the population of a country in different areas. So for example, here's one variable, the population, and here's the other one, the area. So we can compare, for example, the population between Sydney and Melbourne, or New South Wales and Tasmania. So we're comparing always two variables. Now let's start with the first one, which is a line graph. Sometimes you will see, instead of having these points in a straight line, like very neat, like in this case, sometimes the points will be all over the place, so they will tend to go either upwards or downwards. That will be the trend. That will be called a scatter plot. But here we just start nice and easy. And what I want to focus here is on the features of the graph. So let's start with these two lines here. These two lines are called axes. Very originally for us, this is called the horizontal axis, and this is called the vertical axis. Now in science, we go a step further and we put them a different name. We are going to call this line here the dependent variable. This is where we're going to put what we are testing for. So for example, here we are testing for the temperature of water that we are heating. So we are testing what happens to the temperature as time goes by. So as you can see from the graph, when we're heating the water, it will tend to go, the temperature will rise to a certain period. Now this one here, that's for the vertical. For the horizontal, we will call it the independent variable. Other things worth mentioning is a title. You need to provide us some sort of information, and the title will sort of summarize what the graph is going to tell us. So for example, temperature of heated water, I know what it means. We're going to see a graph where we see some temperature units and what's happening to. So does it go up or down? Now, let's look at these. You must label your axes. Sorry. You must label them. Otherwise, we have no idea what you're talking about. If they're blank, well, yes, it says has a title, but which one's which? What are you testing? Against what you tested it? And notice these brackets here. Those are units. So your label will be without brackets, your units, wherever possible. If you have units, put them in brackets. So if you want to repeat the experiment, you must use Celsius and you must use minutes. Another thing worth mentioning is the scale, the numbers that you're using. So for example here, the scale goes up by 1, 0, 1, 2, 3, 4, 5. But here, you can do the scale up by 20s. 0, 20, 40, 60, and 80. It doesn't have to be one by one all the time. It can just be, you can do up by 30s, by 40s if you want to, but normally a nice scale will do. But you must stick to the scale. You can't do 0, 1, 2, 3, 5. No, you must do 0, 1.3, 4, and 5. Now this is quite useful because then you can say, well, what was the temperature between 0 and 1? So let's say half. So you can, oh, it's up here, either there, and then look across. So roughly 58 degrees. You can say something similar. For example, what's the temperature between 60 and 80? Well, it will be 70 roughly. And then you can look across. How long did it take to reach 70? Roughly 2 minutes. So as long as your scale is neat, you can deduce what are the numbers between them. Now here we have two more graphs, and I do apologize for the lack of space. We have column and bar graph.